My name is Joel Crawford, and this is my 3D scanner build for AERO 4842. We can see it's a pretty basic setup. It has two servos connected to an Arduino Nano, and then a sensor connected to the Arduino Nano. This is the LIDAR sensor, however the SONAR sensor looks about the same. The breadboard layout for this is relatively basic, however all of that is outlined in the report. We can see next what the setup will do under testing. Okay, so I just hit run on the scanner. This is the SONAR scanner, so we can see our test bed, which has a slanted angle in a binder. It has a book and a box with variations in height, and you can also see a sort of valley feature between the binder, the box, and the book. So we have the scanner running here. You can see that it sweeps back and forth along one axis, and as it reaches the end, it tilts up along the other axis by 1 degree. This gives us 3D scanning capabilities. So the scanner's running here, and it is MATLAB is plotting the data points live. We can see here there's a outlier. That's just some noise from the sonar, but that's okay. This does take a few minutes to run, so I'll come back when it's done with the 3D surface plot. Okay, so the scanner has stopped running here, and the MATLAB has output a 3D plot. We can see that it is essentially completely inaccurate. It has a slight rounded shape. That's just from noise from the sonar from picking up indirect waves. This section over here, which goes down, is due to that the bad outlier signal that we received right at the beginning of the scan. But yeah, so this data is not very good. It's not readable. You can't see the height differences between the box and the book or the binder. You can't make out the valley. There's really no readable data here other than that the scanner is picking up some object at a distance away from it. We'll see the differences of how this compares to the LIDAR, which is much more accurate. Okay, so I've just plugged in the LIDAR scanner and got it to start running here. You can see that the setup for the scanner is essentially the same. We've just swapped out the sensor there for a LIDAR rather than a sonar. So it operates on the same principle of sweeping back and forth along one axis, and at the end of each of those, bumping up by 1 degree along the other axis. Still with the same test bed, and so it's running the test in the exact same way. We're also doing a live plot in MATLAB. And again, this will take some time, so I will come back when the final results are up. Okay, so the scanner has finished going here, and we can immediately see that these results are much more accurate. Panning around, we can see clearly the book, the box, and then the binder. We can see a slant in the binder from the gradient. It goes from green to orange yellow at the top. Yeah, these results are just clearly much better from a top-down view. We can clearly see what matches the top-down view of the test bed. And so this is a lot more accurate. Taking measurements from this gets us very close to what is done here. That's outlined in the report. But yeah, so the LIDAR proved to be a lot more accurate in this test. There's still noise, still variation in the height, but it is much, much better than the sonar, which was giving essentially unreadable results. And so that concludes my 3D sonar and LIDAR scanner build. Thank you for watching the video.